In the book Chances, Risk, and Odds in Everyday Life, the author says that there's a 72% chance a polygraph test will catch a person who's lying, and there is a 7% chance that the polygraph will falsely accuse someone of lying, if they're actually telling the truth. If a person answers 10% of a long battery of questions with lies, we want to know what percentage of the story will the polygraph correctly indicate as a lie. So when we want to start this problem, we'll label some of our events with symbols just to make things neater. What we have going on here is the events that the polygraph says you are lying. And then we have either the person is lying, we'll call that L, or the person is not lying, we'll call that one N. So what we have in the problem is the probability that the polygraph says the person is lying, given that they actually are lying, that's 72% or 0.72. The probability that the polygraph says a person is lying, given that they are not lying, is 7% or 0.07. And we know that they're going to lie on 10% of the questions, so the probability the person is lying is 0.1. We want to know what percentage of the story is going to be correctly indicated as a lie. So we want to know the probability that it says you are lying and that you are actually lying. So we can use the multiplication rule, since we don't know that these events are independent, that says if you want the probability of one thing and another, you start with the probability of one of them, so we'll do the probability of lying. You multiply by the probability of the conditional S given L. We have both of these quantities, so we take 0.1 times 0.72, and we find that we get a probability of 0.072 or 7.2%.